What's up, Sci-Fam? It's your boy Nickel, and today we're going to look at something we know as the greenhouse effect. Something that happens here on Earth, and so we'll look at the Earth's atmosphere and how it's responsible for creating this thing known as the greenhouse effect, and how certain gases in our atmosphere actually allow our Earth to reap the benefits of a greenhouse. So, the greenhouse effect, the most important player here, the star role, is Earth's atmosphere. Without Earth's atmosphere, we would not have the greenhouse effect. So let's think about this idea. It's called the greenhouse effect. Well, a greenhouse, if you've seen one, you've most likely noticed that you can see the support beams in the greenhouse, or at least you can see parts of the structure that builds the greenhouse. And that's because the walls and the ceilings are a translucent color, or it lacks color because it's translucent, and that allows the sun's light energy to be able to enter into the greenhouse. And that's really important because in a greenhouse we're trying to grow plants, and really the purpose of a greenhouse is to grow plants but protect it from the outside air, because usually the outside air is a little bit more cool. So what happens is that this light energy enters the greenhouse, is absorbed by the materials in the greenhouse, and then when the infrared heat tries to escape, it can't escape. The material in the greenhouse reflects the infrared heat, or at least most of it. So the inside of the greenhouse warms up and light comes in, and it ends up being warmer than the outside air, which helps plants be able to grow earlier in the season or later in the season when the air temperature isn't conducive for plants to grow. So we're going to apply that idea and that concept of the greenhouse to understand the greenhouse effect, and maybe you get it now, I don't know. But Earth's atmosphere, if you didn't know, which you probably do, because we breathe it every day, hundreds of times, Earth's atmosphere is just a layer of gases that surround Earth's surface. Now, not all planets have an atmosphere. We're lucky that we have our magnetosphere, because the magnetosphere actually allows our gases to stay here on Earth and not get pushed off the Earth by solar winds and solar flares and stuff. So that's really good that we have that magnetosphere to keep us all able to breathe and life to be able to sustain here on Earth. So our atmosphere is composed of some elements, or composed of some molecules that are all gases. And these gases are some that you may not be familiar with, because some of these gases that are in our atmosphere are more important and some of them are less important to us as humans. So as we grow up, we learn about some of them, but not all of them. So the very most abundant gas in our atmosphere, at 78.1% of our atmosphere, is a molecule known as nitrogen. So this gas is called nitrogen. It's a molecule. The molecule is nitrogen. So that means it's made out of more than one atom. So the chemical formula, or the chemical formula for nitrogen is N2. And that's because there's two N atoms, or nitrogen atoms, that are connected together. And when they connect together, we call that molecule nitrogen. The second most abundant gas in Earth's atmosphere, at 20.9%, is our best buddy old pal, oxygen. Yeah, we love that molecule. And that molecule is made out of two atoms as well. And it's made out of two atoms of the element oxygen. So two oxygen atoms connected together make up this molecule that we know as oxygen. Now, if we add this up, we're at 99% of our atmosphere already is made out of nitrogen and oxygen. That might be hard to believe. It was for me. What's also hard to believe is the next most abundant gas, at 0.9% of our atmosphere, is a gas known as argon. And argon is just a single atom of argon, but it's in its gaseous form here on planet Earth. So now we're at 99.9% of our atmosphere. What's pretty crazy is all of the other gases that are in our atmosphere are part of this 0.1% that we're going to call rare gases. Now, they might be common in terms of their names to us, but in terms of their abundance in the atmosphere, they're rare. And these are things such as carbon dioxide. I'm sure you've heard about carbon dioxide. If you've ever heard about the greenhouse effect or even heard people talk about the atmosphere, carbon dioxide is typically a pretty famous person in this discussion. Or not person, obviously, but molecule in this discussion, carbon dioxide. But it actually makes up it's only a portion of this 0.1%. So it makes up a tiny part of all of our atmosphere. That's how important it really is. Also, some other rare gases that are in our atmosphere. One of them you might be familiar with, water vapor. Yep, so like clouds or just the humidity in the air actually is a gas that's in our atmosphere. And another one that you may have heard of could be something, maybe you've heard of methane. Okay, so this is the composition of our atmosphere. But not all of these players and not all of these molecules in our atmosphere cause the greenhouse effect to occur. So let's dial in here and really get to know what it means what we mean when we say the greenhouse effect. So let's define greenhouse effect. Okay, some gases, not all of them, some gases in our atmosphere are going to absorb and also reflect. Some gases in our atmosphere absorb and reflect back to Earth's surface. But what are they absorbing and reflecting? Well, something I forgot to add here that we should add here is they absorb and reflect infrared radiation. Okay, let's zoom in on that. Infrared radiation, that's important because that's heat. See how I drew that there in red? Well, infrared radiation is the heat type of radiation on the electromagnetic spectrum. Infrared is how we call it heat as humans. So some gases in our atmosphere absorb and reflect infrared radiation back to Earth's surface. All right, so our Earth heats up, and then it gets rid of that heat just like our bodies do when we heat up. But what's crazy is that we have these gases that reflect some of that heat back to us. All right, so these gases that do this job are known as greenhouse gases because they are capable of absorbing and reflecting that infrared radiation. So let's look at, what are the greenhouse gases? The most famous, CO2, also known as carbon dioxide. So carbon dioxide is the molecule name, and the molecule is made out of a carbon atom and 2 oxygen atoms. That's why we write CO2. The 2 below the O in the down subscript area means that 2 is going to go along with the O, only the O, and the O stands for oxygen. The C actually has a 1 there because we only have one C, but since there's only one, we don't even put the 1 there to save time. So carbon dioxide is the molecule name, and the chemical formula is CO2. Another common greenhouse gas is methane. And methane is made out of carbon and 4 hydrogen atoms. So a molecule of methane is made out of carbon and 4. I know there's 4 because the 4 is below the H is hydrogen. So 1 carbon and 4 hydrogen atoms makes up the chemical formula. Another common greenhouse gas is nitrous oxide. And nitrous oxide is, the chemical formula at least, is N2O. And another type of greenhouse gas that is a really important one to know about are things that we call fluorinated gases. And so fluorinated gases are any gas, so we'll just put an X here, that's attached to a fluorine molecule or a fluoride molecule. Fluorinated, fluoride, we get fluoride is F. So F sub X, we just put the X there because it's some other gas is going to be attached to that fluoride molecule or that fluoride atom, making a fluorinated gas molecule. Now the reason I'm calling these ones common is actually more related to, these are the important ones because they all have a significant effect on producing this greenhouse effect here on Earth. So carbon dioxide is responsible for 81% of all of the greenhouse effect here on Earth. Methane is responsible for 10%. Nitrous oxide is responsible for 6%. And fluorinated gases help our Earth warm up and stay warm. At least 3% of that process of the greenhouse effect. Fluorinated gases do that job. So we can see the reason that we typically hear about carbon dioxide is because when it comes to the greenhouse effect, it has the biggest impact on our Earth. It makes up 81% of our current greenhouse effect. Methane, you might have heard that one as well, because that one is the second biggest player in the greenhouse effect because it is responsible for 10% of that effect. So down here I drew a little model of the Earth. And we have different gases in our atmosphere. So I drew these little bubbles here to represent some of these gases. So let's say here we have a CO2 molecule. Let's say over here we have a methane molecule. Oh, we have a cloud here in the middle, and the cloud is made out of water, and water vapor is a greenhouse gas. Remember, there's tons of nitrogen in our atmosphere. So we might have a nitrogen molecule. Let's say we have a nitrous oxide molecule over here. Another one of the common gases in our atmosphere that we know of is oxygen. So let's do an oxygen molecule over here. And another one that's in our atmosphere is argon. So we have all of these different molecules, gases, gas molecules that are floating around in our atmosphere. And what we see is that, let's take a yellow here to show that sunlight comes into our atmosphere. And since our atmosphere is transparent, the sun's light is able to enter our atmosphere. And it hits the land and it warms up the land, and it hits the water and it warms up the water on the Earth, which causes the water to evaporate and create clouds and rain and all that good stuff. So the sun's light comes in, it heats up our surface of our Earth. And what happens is that the surface of the Earth then emits infrared radiation. And infrared radiation is emitted. If it hits, though, a greenhouse gas, that greenhouse gas is actually going to absorb and then reflect that infrared radiation back to the Earth. So carbon dioxide is going to absorb the infrared radiation and then help, kind of like a blanket, trap that infrared radiation so that it reflects back down to the Earth. Also, same with water vapor. Water vapor is going to absorb the infrared radiation and it's going to reflect it back down to the Earth. Methane is another one that will absorb the infrared radiation and reflect it back to the Earth. Nitrous oxide will do the same thing. It will absorb infrared radiation and then reflect it back down to the Earth. I want to show this, that these arrows are going up here because the infrared radiation typically will just rise from the Earth. Like, for example, if we have argon here, argon is not one of the greenhouse gases. So infrared radiation would not get blocked by argon. Argon does not absorb and reflect infrared radiation. So some infrared radiation is lost out to space. Another example here is nitrogen. Nitrogen is not a greenhouse gas, and good thing it's not, because it makes up most of our atmosphere. We'd have a lot hotter of a planet if it was a greenhouse gas, but it's not. So something that you can use to test this idea is if you ever see that outside at nighttime, it's really, really cloudy, you'll notice that the temperature doesn't change as much at night. And that's because the infrared radiation is actually leaving the Earth, but then it hits those clouds, that cloud layer that's above you, and it helps trap some of that infrared radiation or that heat in your area. If there is no clouds, if it's a nice starry night, you'll notice it usually is really, really cold because that infrared radiation is just leaving and going up into the sky and is released into space. So all of these greenhouse gases are really, really important for us here because it helps us keep our Earth cozy, as I said. So if we didn't have them, without greenhouse gases, our Earth would be either too hot, if we were facing the sun and we didn't have an atmosphere, the sun might just wipe us out because the atmosphere actually blocks some of the radiation from the sun. So if it would be too hot during the day, and at night when we weren't facing the sun, if there was no atmosphere to trap heat down to our Earth, it would be too cold during the night. because we wouldn't have that blanket. It's basically like a blanket. And without the greenhouse gases on Earth, it would either be too hot during the day or too cold during the night to sustain human life. There might be other life that could form. I don't know. We don't know that. But at least for humans, we would be pretty screwed if we didn't have a greenhouse effect here on Earth. So it is a very important thing that allows our Earth to be habitable. And now you know. And I will catch you on the next video.